Klara has actually been involved with the Australian hemp industry for 16 years, both in the farming and then also the building sector. Now, she has been in the forefront of getting hemp lime masonry and also hempcrete into the Australian sphere. And through her research at the University of New South Wales, they were able to develop the low embodied carbon BCA building construction of Australia compliant hemp lime building material that she'll be talking a little bit more about today. Her company has supplied almost 42 builds in all over Australia and has also been a part of Singapore's first zero energy public building. Klara is actually here also doing a workshop on hemp masonry and hempcrete. So if you want to get along to that, I'm pretty sure there's still a couple of spots available as well. But I'll just hand it off to Klara now.
Thank you. Thank you very much. Yes, so my involvement in the hemp industry started in 1999, and I actually came into the hemp industry from working in environmental management, so in river and land management. And I had been involved as Greening Australia's rep on the forest consultations in the Wadigan Mountains in the Hunter Valley. And that's when I really got an understanding of the fact that people love to live in organic materials, and also got a really good understanding of what goes on in forestry. And I'm, not goes on, but, that the process of harvesting timber means that an enormous amount of timber gets harvested and we get very little usable timber out of that. And that forests really are resources that should be there for air and water and, medicines and all of those multitude of other things that we need, that we're just now starting to understand when we talk about costing ecosystem or valuing ecosystem services. Am I pushing this? Fantastic. I'll just quickly go through, I've got quite a lot of slides and I'll go through them quite quickly, and hopefully people will pick up afterwards in question time. So this is actually at Bordertown, which is quite interesting because it's the closest commercial site for growing hemp to South Australia. That was planted last year. They have issues in Victoria still with processing. But there's a really strong network. I'm also president of the Australian Industrial Hemp Alliance that was formed last year, and I suppose in some ways we're fortunate in New South Wales. We were one of the last states, even though you're behind us, but we were one of the last states to get commercialisation through, and because other states had, we knew what we were asking for. So we have, good legislation there. And so there's a very good support network coming out of New South Wales for farmers in anybody interested anywhere in Australia in growing hemp commercially. So that's what we're after when we plant. So we plant at 40 kilos per hectare, and we're after growing wood. So it's a bit of a myth that it's about the leaves. The reason why it's exciting though is because you get incredible canopy cover and canopy closure very quickly, so you can grow it without herbicides. And largely without pesticides as well. The other thing that's interesting about it is this is actually a dryland crop that I was involved in northern New South Wales. The farmer was growing soy crops at the same time. We got massive hailstorms through. He lost his soy crops. The hemp survived, and it grew to 2.5 metres, and that's actually the equivalent of what you'd get if you were growing a European variety in Europe. Okay, so we actually, in New South Wales, and there are seed varieties available, so equatorial varieties, where we're growing 4 to 5 metre plants. So this is a really lovely site for me. I've had a lot to do with this farm because it actually looks at the model of small farm and whether two people can survive on a farm and grow hemp, grow a little bit of lucerne, have a few pigs and a few sheep, and that's literally what it is. Used to be a tobacco growing farm. They were interested in organic farming. We couldn't get organic certification because there was still residual DDT. But as you'll sort of see in a couple of slides along, I'm focusing on this environmental perspective of hemp because the bioremediation capacity of hemp is quite phenomenal. And so really, I suppose more than talking just about my own business, which is about building houses and getting that accepted in Australia as a building material, I'm probably almost more passionate about getting hemp farming happening for carbon management. So yes, minimal irrigation even though we were on the side of a river there. So what we were looking at is how little could we put in there, and would it be possible for small farmers to stay on their farms and keep those going, because that's actually a major issue in Australia. So this is Dungog, really exciting. I went back, so I worked with these farmers 25 years ago when I did work with Greening Australia. They formed a co-op of 13 farmers. They bought the old timber mill that had been closed down. They got it for the value of the land, and it's now a hemp mill. Shepherd's Ground is an eco-village that will start in a few weeks' time. It's actually a biodynamic share farming eco-village, which kind of links in here with the story of biodynamic farming. It's about 15 minutes from Maitland, which is a major regional centre. All of the houses for that are going to be, they're quite small designs, and but they're all going to be built out of hemp. Okay, so that's what a fibre farmer is producing. The bast is what's on the right-hand side, the herd is on the left, and I actually had a sample of that here. So very, very much about wood production. What happens when you grow hemp is you plant them so closely together that they lose all of their leaves, and they are competing so hard for light that you just get wood with a little pom-pom of leaf on the top of it. The edge plants always look a bit stunning because they've got, you know, a lot of leaves and branching happening there, but inside, if you walk into a hemp crop, you literally have to put in a tape so that you can find your way back out of it. It's 5 metres high. It forms its own ecosystems within a hemp crop, within the wood. So the building material is the material that we're using on the other side. This material that I'm calling bast, which is the hairy material, is what goes into biocomposites. So in Europe they're manufacturing cars out of that. I don't know whether anyone's seen in Scotland, they're making sunglasses out of it, they make tractors out of it, etc. It's also what you get textiles out of, and you know, insulation matting and products like that. So industrial hemp's pretty exciting from the perspective that it's an annual crop. It's really good in a crop rotation, and there's been enough research to show that if you grow it in a wheat rotation, for example, you'll get a 20% greater yield from that. It also harvests a phenomenal amount of carbon because it grows such a huge biomass so fast, so in 90 to 120 days. Just so you can see there that the bulk of the carbon is stored in the herd or in the stem of it. There's very little in the leaf or the head of the plant. UK research tells us that in addition to the carbon that we're harvesting off the field, we're also adding a ton of soil carbon to the soil, and that's coming from the leaf drop that comes from that competition between the plants, the long taproot and the stubble. So interesting also, because I'm starting to do some work with some Japanese researchers, is this research from the Belgian Nuclear Research Institute. So very effective at cleaning up irradiated land. That might have some application in South Australia. And just because you're on the edge of that industry, so I guess it's a possible thing to think that that's a scenario. Obvious application for Japan. So you can harvest the fibre. You can't use the root ball and you can't use the seed head, but the fibre can actually be used for industrial purposes, and the Belgian Nuclear Research Institute's done quite clear measurements on what levels of radiation you can clean up with hemp. Also sort of used for removal of heavy metals and other toxins. A project that I was involved with in Bangalore was called the mop crop, and what we did was we grew hemp on a tertiary treated sewage works and got a yield of 22 tonnes per hectare, and it cleaned all of the effluent before it went into the Bangalore Creek and into the northern rivers, into the ocean there. So it's got real value in soil remediation. Just in comparison to other conventional crops, it's sort of, you can see that industrial hemp, both for food and for fibre, sits very nicely on the other side there, compared to a lot of plants that we don't really think about growing, but grow all the time. And it's the point that we were making earlier, is that when we talk about straw, we talk about hemp, we're sort of measuring how environmentally friendly it is, and at the same time there are all of these products out there and nobody's measuring anything at all about the marble slab that somebody has in their kitchen that has been shipped to Australia, or any other product for that matter, probably that you see in Bunnings or somewhere else like that. Interesting for Australia because of the varieties we're growing. You can see by comparison with Europe that we're getting 12 to 15 tonnes per hectare happily as a yield from farms. And then just to explain how that relates to carbon. So when you talk about a crop harvesting carbon, what they actually measure is how much heating effect it prevents from occurring. So it's measured when you're talking about global warming potential. It's actually 1.7 kilos of carbon for every kilo of carbon that you're growing in field. And we're talking about, that at a minimum we're harvesting between 12 and 15 tonnes. So it's actually quite a huge amount of carbon that potentially is coming out of there. So to give you a quick idea, and I've got lots of pictures in a minute, sorry. For a tiny cabin, so a 48 square metre cabin that you would expect that you would do the hemp walls on in 6 days. And in that you would have locked up 2 tonnes of hemp. That's if you're not using any for subfloor or for roofing insulation, you're just using it in the hemp walls. And then, larger home, 4 to 6 tonnes. And then this is sort of talking now about commercial applications in the UK. Marks and Spencer have just done it's the world's first carbon neutral retailer, and they've averted 360 tonnes of carbon emissions by building with hemp on that build. So carbonation is a process, just in case anyone isn't familiar with it. When you're working with a hemp building material, you're working with a lime binder and with hemp hurd. And then the curing takes place in a process called carbonation, where it's actually drawing in carbon dioxide from the atmosphere for the material to set, rather than kiln drying it like you would with a conventional brick, so it's been baked beforehand. So it's low embodied energy product. Talking about life cycle analysis, because it's something that we all need to be starting to be aware of. So really you need to measure all of the inputs to a whole process before you're claiming that something has got a really fantastic value in terms of carbon management. So freight, footprinting, everything to do with the farming, everything to do with the mining, everything to do with the manufacture and any waste that is left after the process. And when you're talking about a building material and you're talking about the performance or life cycle analysis, you're measuring usability, durability, recyclability, energy efficiency, air quality and health, and then you should be doing that comparison with the marble slab. So just to get an idea, because freight is something that is talked about a lot when we talk about carbon management, is that in this study that was done in Germany where they've actually moved hemp 300 kilometres, what they've found is that the biggest single input is not in the freight, it's in what fertiliser you are using as a farmer. And so when we talk about greenhouse gases, you'd all probably be aware that we're talking about 3 major categories. We're talking about carbon, we're talking about methane and about nitrous oxide. Nitrous oxide has got far greater warming potential than carbon. It's just that we've got mostly carbon. But the major production of nitrous oxide is from conventional farming, so from chemical fertilisers. And it's huge, and it's got, I think it's 298 times the warming potential of carbon, and it's got a much longer lifetime as well. So it's really quite a significant thing to look at how do we farm, how do we change that, and what are we calling sustainable in this whole picture. So you can see that transport, and it's only over 300 kilometres, and this is something we really have to look at in Australia because we've got vast distances. But it's actually the fertiliser that is the biggest issue. So obviously sustainable farming is what you would want to be promoting. Similarly, in processing, you can see there for insulation products, when you're looking across the spectrum, that in terms of energy, hemp fibre production and processing is very low energy intensive. The binder, the billion-dollar question, what is the binder that we work with? So the material is huge volume of hemp and a very small amount of binder. We did research at New South Wales Uni for 6 years. I was very fortunate that my brother was the founding director of the Australian Centre for Construction Innovation, who was a concrete specialist. So for 8 years I hassled him about hemp building materials until I was able to get some testing done and able to get his attention, because he's very well regarded for multi-storey concrete structures and tunnels under oceans and things like that. But he thought that I was totally crazy. he couldn't understand why I wasn't after making the strongest material in the world, why it was that I was looking at all of these other things. So just briefly there, in Europe they use hydraulic lime. Hydraulic lime occurs on the edge of a lime field and it's contaminated with other elements. We started working with hydrated lime, which is much more commonly available at New South Wales Uni, to see what it was that we could add to that to mimic hydraulic lime, and how could we best reduce the carbon footprint of hemp building even further. And what we found was that if we introduced some fine washed sand into the process, then that enabled us to use quite significantly less binder than other people who were building with hemp building materials. That's the material on this side, on the right-hand side. You really are literally very quickly tossing the hemp hurd into the binder material, putting the sand in. It's probably a 2 to 3 minute mixing process. It's very fast. That's the material after a few weeks on the other side. This is a 300-year-old hemp house, Miyasamura in Japan, and I've put that there to give some context on durability. Did I do that? Yeah. So just to give some context on durability, so that's an existing building there. We obviously don't have any kind of records like that in Australia yet of buildings, even though we've had things that have, or builds that have been up for close to 10 years now. But we're expecting very high durability. This is probably what inspired me most to get involved with hemp, is when I could see that you could use it in all sorts of different ways. I felt that of the natural building materials, it was perhaps a little more flexible than some of the others. And in saying that, we earlier just had a conversation about straw bale panels, you know, so there's definitely room for that. But this is, you know, a pretty upmarket looking French accommodation where they have refurbished entirely with hemp, because you can retrofit, you can restore, you know, so you can work on historic buildings well because it's a breathable material. You can use it at different thicknesses, so it's a very flexible material. So if someone's just got an old house and they want to retrofit for energy efficiency, then you can retrofit internally and thicken the walls, or externally, or you can do a new build. And I'll actually, in some of my photos, you'll see some examples of those. So performance characteristics, I've already covered the first couple. The reason why it's considered to be a really effective material thermally is because it's a slow phase change material. So it takes longer for the wall to heat up and to allow the warmth inside than it takes for the change between daylight and night. So you actually have an environment where the building doesn't heat up from the outside temperature. It mitigates humidity very well. So they did some testing at the Centre for Alternative Technology in Wales, which they would describe as probably the harshest, or the researchers described as the harshest environment that you could build in. And they compared drywalling with hemp retrofitting over a wall that was damaged because it had moisture in it. And they found that the hemp was far more effective than drywalling because it will continuously wick off the moisture, and then that will dry out within the building. So the big bonus is that you don't get mould growing. And the big bonus of that is that moulds are related to all sorts of respiratory allergies and a whole lot of other allergies as well. So it becomes an air quality issue. That's just to show the moisture buffering going on within a wall, showing how it's behaving. And I'm sorry, it's really not a very good graph. It looked much better on the plane when I thought about adding that in as an afterthought. It's non-combustible, so hemp masonry building materials, you can't ignite them readily at all. You should have no waste on your site whatsoever, so anything that is that falls to the ground you would pick up. You can reuse that in your mix for up to 6 hours, or you can set it aside and reuse it at 10% into your mix tomorrow. So there literally should be no waste on the site at all. Like straw bale, it's airtight construction and like rammed earth. It is lighter than most other masonry materials, so my first builds that I did actually involved some elderly women alongside myself in that build. My first build was actually for an Aboriginal elder who was a friend of mine, and what I was interested to see was whether our Aboriginal community was interested in hemp building, rather than going forward and saying, you know, this is something that I would recommend And that building has actually been really successful in that kind of way, that it's given me very good feedback. Can be combined well with other materials, very effective in historic restoration, recyclable, so if you've got leftover material, you can just put it out on the garden if that's what you would want to do, or you can put it aside in some bags and you can add some binder to it in 10 years' time and reuse that. Or if you're, taking it down and you just want to deposit it somewhere, you can put the dry material out on your garden. Easy skill, building skill to transfer, and I think that there's a lot to be said for that, because it does mean that you can teach owner builders really effectively, you can work with communities very effectively and get some really good outcomes. Most common use, external walling, generally 200 to 250 millimetres. Internal walling, the wall thickness should be governed by the climate zone, and they're the R ratings. And so while they're adequate, you can see from the earlier presentation that straw bale does give you a higher R rating. It's really about deciding what is available to you. This is certainly, with hemp, it is easy to meet the various requirements by different governments in different states. Okay, so this is feedback on a 2-year project that was done in the UK. So the UK funded to the tune of 6.3 million, 283 buildings, and then they went back and they assessed those after 2 years of them being inhabited. And what they found was that they had energy savings corresponding to 50 to 80% lower than in conventional brick and block. And then that point at the end is that when you compare an average brick and block house and a hemp house, you've got a plus 10 footprint from a block and brick house and a minus 4 tonne footprint from a hemp house. So you're talking about zero energy. And now I'm going to fly through slides. So this project, the triangle that people would have seen on television, Kevin McLeod's project, was one of the monitored projects. So again, same findings. Adnams Brewery, really interesting building because yes, 500 millimetre thick hemp walls, but no air conditioning in a brewery is a pretty nice achievement because it means there's no ongoing energy cost whatsoever, and they maintain this constant of 12 to 13. This is the London Science Museum where it's been installed to manage humidity so that their aeroplanes and cars don't rust. So that just relates back to the point that I was making about mitigating humidity. This is a house in the Northern Rivers, and we'll just fly through some Australian builds. So this is up near Mullumbimby, and I've added this photo because I wanted to show, that people have embedded some slabs in there, which I personally think is really beautiful. This is a house at Protesters Falls where the frame was already up. It had been harvested on the site from blue gum. And these studs were 120 millimetres wide, so we just fitted the hemp in between those. Owner build in Bateman's Bay. This is a recent build in Marrickville under the flight path. Quite a schmick looking inner city extension and renovation. It's the first city build in Sydney. And we obviously had to meet the acoustic engineer's requirements for sound there. This is in Victoria, so it can be completely covered and line rendered so that you never look at it again. But nearly everybody who builds with it actually leaves some more walls exposed, and then they're just sealed with a clear, breathable sealant. It's actually a very beautiful material. Not that I'm biased. There's a technique to building with it. You can build very ordinary walls or you can build beautiful walls. And that's a feature just next to somebody's front door there where you're actually layering the material in so that you see those lines. And it actually, as it gets older, it just looks like sedimentation lines in rock formations, which is quite lovely. And then on the one on the other side is actually at Shepherd's Ground at that eco-village, and they've got mineral oxides mixed in with it there. Deep Ecology Centre, not rendered at all inside other than around the windows. Retrofit in Canberra where they've built Australian houses in the 1960s with 40mm thick walls and no insulation. So everyone in Canberra pays an awful amount of money for their energy costs, for cooling and for heating. So the opportunity to retrofit an old house, worked very, very successfully there. This is the CDL Green Gallery, which I didn't ever think that I would do a build overseas at all because I'm always going on about domestic industry, but that's what they consider to be regional, and then in the end it was just an amazing opportunity to have a build in a public place when Nobody else was even considering it for public buildings at the time, and it's a beautiful building. It's green walls in between hemp walls, and it's actually modular construction. So it's just, I think I missed that, but it's suspended on an L-beam, so it's actually a steel modular construction with purlins welded to it, an L-beam at the bottom, and the hemp is sitting on that. So virtually every kind of building context that you can think of, you're able to use the material, whether it's standard stud, whether it's pole structure, whether you're building it onto stone, whether you're retrofitting or restoring an old building. It seems to be, you know, it adheres well to those materials and seems to be very, very effective. Thank you very much. I'm sure I've gone a couple of minutes over.